Okay, so third day of quadratics. Remember, what is a quadratic? It is basically an equation that's of second degree. What does second degree mean? That there's a variable squared. That's the highest powered term, variable squared. When you see a second degree and you recognize it's quadratics, you should be thinking two solutions. And then you should go into this mode. This is what your next thought should be. I have three ways I can solve quadratics. I can solve quadratics by taking the square root of both sides. That uses the zero product property. By factoring, setting it equal to zero factoring, that uses the zero product property. I can solve quadratics by taking the square root of both sides. That's if there's no variable, the first power term, or if it's a special situation. And then the third way I can solve by using the quadratic equation. We haven't learned the quadratic equation yet. We're getting there. With all of that comes a methodology to fit a quadratic into the format that allows you to take the square root of both sides. And that format is called completing the square. You should learn the name, not so much that you need to answer a question, but I'll refer to completing the square, and therefore that should trigger a memory in your brain. So completing the square. So this is a means that will allow you to not only solve a quadratic by taking roots, again taking the square root of both sides, but this is also what will help you to get a quadratic into the proper graphing form. So it will help you to graph quadratic functions. Completing the square. It's a concept that comes up occasionally the rest of your math career, especially as we get into second degree quadratics and higher, third degree, etc. The concept of completing the square. Completing the square comes into play not only with quadratics, but with a lot of related things. The graphing form for circles, the graphing form for ellipses, the graphing form for hyperbolas, all of those things tie into completing the square. So it's got some value, and so we need to keep track of it, and we need to learn the method. All right, how do we start? It creates a perfect square trinomial. So it creates a perfect square trinomial, meaning you make a perfect square trinomial. That may not mean a lot right now. It's just a bunch of words. I'll show you what I mean by that in a minute. But once we have that perfect square trinomial, if you read the rest of the line, it says that we can factor to its binomial squared, and I'll show you what I mean by that in just a moment. And the key to all of this is the value of b, and I'm going to do that in green because the b is in green. We use the value of b of standard form. All right, I started the whole chapter with standard form of a quadratic equation. It was ax squared plus bx plus c equals 0. Where a, b, and c are simply numbers. The variable is the x, second degree obviously, and therefore quadratic, and therefore up to two real and or imaginary number solutions. Okay, so let's get right into completing the square and see if we can learn the methodology. All right, so we're going to complete the square. Help you out, I gave you your thoughts along the right. So this is what you should be thinking if you're going to do the method. Therefore, this is what you have to learn if you're going to do the method. All right, first thing, isolate and group the variable terms. Sometimes they're not isolated. Earth to daydreamers, not a good time to daydream. Okay, what are the variable terms? In this one, it's the x squared. Let me go to red here. In this one, it's the, you don't need to do this in your notes, you'll just clutter them up. It's the x squared and the 6x squared. Those are the variable terms. They need to be isolated. Guess what? In this example, they are already isolated. They are already grouped. All right. So we do, though, add a, and you can do this in red, a parentheses. Don't make it little. Then stick in the front of the parentheses the x squared plus, and I'm going to keep that 6 in green, x squared plus the 6x. Keep it still equaling 16. So at this point, we haven't really done anything to the equation except grouped the variable terms with a parentheses. Everything else is exactly the same. Agreed? And the values are exactly the same. Nothing has happened so far. All the values are the same. That's all we've done. What we're after right now, this is where we're heading. We need to stick a number in here that will make that a perfect square trinomial. That's what we want, a perfect square trinomial. So we have to find the number to stick in there that will make it a perfect square trinomial. That's what we're after. And it's not so hard to figure out. The way you figure out what number to stick in there is this second step. Divide the b by 2, square it, then place its value in the parentheses. Okay, so I'm going to take my green here. The b is a 6, correct? I'm going to take my blue, I'm going to divide it by 2, I'm going to put it in a parentheses, and I'm going to put a squared out in front of the parentheses. So I take the b, I divide it by 2, and I square it. You should all have this. Everybody should be writing this in your notes. This is what you're doing. The 6 divided by the 2, and then square it. And it doesn't take a rocket scientist to figure out that the value is 9. Will this value ever be negative? No. Even if the b was a negative 6, negative 6 divided by 2 is a negative 3. Negative 3 times negative 3 is a positive 9. This value is always positive, always. Because you're squaring it. It's got to end up positive. If it's positive, it ends up positive. If it's negative, it ends up positive because you're squaring it. All right, so it's a positive 9. So divide, number 2 says divide the b by 2, square it, then place its value in the parentheses. So it goes right here. See, we just found the value that's going to make this a perfect square trinomial. And x squared plus 6x plus 9 is a perfect square trinomial. We'll get back to that in a minute. However, we have to do the next step as well. Add the same amount on the other side. Add the same amount. So I'm going to stay in blue here. Now let's do it in green. We'll follow the color coding. I added a 9 to the left. I'm going to add a 9 to the right. Why? Why did I just do that? Why? Nick? You got to even out the equation. Look, if we stick a 9 on the left, was that 9 there to begin with? No. We stuck it in there. We added 9 to the left-hand side of the equation. So we've just changed the fact that the thing's equal. Well, until we put a 9 on the other side, now it's still equal. You know, simplistic thought, if I got 50 on the right, and I got, well, that's your left. I got 50 on the left, and I got 50 on the right. If I add 9 here, I now have 59. What better I do? Add 9 here, and I'm balanced back out again. 59, 50. That's all we're doing. You got to maintain the balance, right, of the equation. So we put 9 in on the left. We got to add 9 in on the right. Next step, factor the parentheses. Now, again, this is always a perfect square, but you may not remember how to factor a perfect square, so we'll just factor it with trial and error. All right, we know the front has to multiply to x squared. That's pretty easy. It's got to be x times x, right? The back has to multiply to positive 9, but don't forget factoring. The outers plus the inners must equal what? 6x, right? You always got to be careful. That's what you're looking for. And look, we only have 1 and 9, 3 and 3. If I use 1 and 9, my middle is going to be 10. But if I use 3 and 3, my middle is going to be 6. Listen, that's the idea of a perfect square. The parentheses are always the same if you did the method correctly. Do you hear that, daydreamers? It was an important thought I just said. The factoring, the parentheses are always exactly the same because that's what perfect square trinomials are. So it's always going to be that way. On the right, we have what, 25? So let me finish up the format. So here I'm going to use my black. So now we have the quantity x plus 3 quantity squared equals 25. That part there is completing the square. We have completed the square. We put it in the format to get a perfect square trinomial, and now it's in this form. All right, so let me tie in with yesterday. All right, take a look at the original equation. If you look at the original equation, you come to this conclusion. First off, it's quadratic. Second, you go through your progression. All right, how can I solve a quadratic? I can set it equal to 0, factor, and solve by factoring. Or I could take the square root of both sides if it doesn't have an x to the first power term. Does it have an x to the first power term? Yep, up rats, because that's the easiest method. Or I can use the quadratic equation. However, if we complete the square, we can solve by taking the square root of both sides. Because didn't you solve problems last night that looked just like that? You did. So completing the square in just a regular quadratic equation does allow you then to finish solving it by taking the square root of both sides. Again, there's more value to the method beyond that, especially in graphing things. So we might as well learn it now, and it's got that advantage. All right, so if we're going to solve the quadratic then, to solve from this point, let's go ahead and take the square root of both sides. I'm going to rewrite this, and I'm also going to take, let's see, what color? Let's take our red and let's just box this in, because that is completing the square, right? The rest is going to be solving it, right? This is completing the square. The whole method is it, but this is now it's completed. Okay, so to solve the problem, it's just like last night. We're now ready to take the square root of both sides, because isn't the squared term isolated? It is. Don't forget the plus minus. We got x plus 3 equals plus or minus 5. All right, see if you remember how to finish it up. If not, you can look up above. I'll be doing it as you do it. Go ahead and find the final values to that. You got x plus 3 equals plus or minus 5. And hopefully you got x equal 2, x equals negative 8, right? X equals 2, x equals negative 8. Completing the square. Any questions so far? Okay, so that's only the first time we saw it. Let's go through it again. And if I use this shade here, I'm going to have to get rid of my shade so I can go higher for you guys. I get in trouble when that thing is right by the box, don't I? Let's see if I can go higher. Okay, so here's where we're at in this second problem. X squared minus 8x minus 33 equals 0. Don't neglect step 1. Isolate and group the variable terms. So what would you do first? Somebody tell me what you would do first. Andrew? Yeah, we definitely want to put the 33 on the other side. On the other side, it's going to be a positive 33. And then we're also going to, on the next line, group our x terms, right? I don't know why I'm in red here, but I'm going to keep my 8 in green one more time to emphasize that. So you got the quantity x squared minus 8x, close that parentheses, equals 33. Okay, figure out what number to stick in the open spot we left. Go ahead and figure out what number goes in there. All right, so hopefully you just took your, and again, you can do -8 if you want, knock yourself out, but it's going to end up positive. So 8 divided by 2 is 4, 4 squared is 16, so you should have put a positive 16 there. How many had a positive 16 in there? If you didn't, I don't know why you didn't. So let me just real quickly go through how you get the positive 16. You take the b value. Again, if you want to use a negative, knock yourself out. Divide it by 2 and then square it. -8 divided by 2 is a -4. -4 times a -4 is a positive 16. Okay. All right, so same amount has to go on the other side, so I put a 16 on the left. I got to add a 16 on the right. All right, now go ahead and factor it and put it in the proper form with the quantity squared. Go ahead and factor it, put it in the proper form with the quantity squared. All right, if you'll just pause for a minute. Do you want the shortcut? Students usually like shortcuts. Because I know this is a perfect square trinomial. Oops, let me just go to blue here. I know I have a parenthesis. I know it's going to be squared. The middle term sign is always in the middle. The square root of the front goes in the front, and the square root of the back goes in the back. And again, if you factored it by trial and error, you would have gotten x minus 4 times x minus 4. You should have. If you didn't, you did it wrong. Okay? So shortcut, because it's a perfect square trinomial, it's always going to be a quantity squared. The sign of the middle term is the sign of the middle. Square root of the front goes in the front. Square root of the last goes in the last. And this thing all equals 49. You would go on to solve it from there. For time's sake, we're not going to solve. But that's what you would do in that situation. You would go on to solve it. Okay? Questions on that? How many had quantity x minus 4 quantity squared equals 49? And again, if you don't, you still don't remember how to factor, and you have to get factoring figured out. You got to get factoring figured out. That's math that builds on itself. Go back and watch the factoring chapters, perhaps, or use the shortcut. You can figure it out. Look, I guarantee. Listen, I'm just look up here for a second. I just want to get you to understand something right now. Here's what I just said to you. Don't write this. If you have a perfect square trinomial, now my brain's got to work, which I don't like. Man, my brain doesn't want to work. Okay. You got a perfect square trinomial. I could teach this to, I guarantee you I can get an 8-year-old to do this. Well, I don't know, square roots? Maybe. All right, 12-year-old. Going to 12. This is always going to be a perfect square trinomial if you do it correctly. What is the shortcut? The sign of the middle is always the sign. Because it's a negative, it's going to be a negative. If that were a plus, it would be a plus. What's the square root of x squared? X. What's the square root of 49? 7. There's the factoring of it. Again, don't make the fact that you're not great at factoring miss these, because it's not that hard. Okay. So C. Go ahead and take it start to finish. I'll be doing it up here while you're doing it at your seat. Go ahead and complete the square and solve it. Complete the square and then solve it. That was interesting. And you should end up at x equal 1, x equals negative 11. How many got that correct? Okay. So same methodology. We were already isolated. Complete the square and solve. All right, let's try another one. Try D. See what you can do with D. Again, you work it at your desk. I'll work it up here. If you need help, take a look up. If not, great. Try to do it all yourself if you can. Hey, can I pause you for a second? Let me just mention one thing. Look, some of you guys, it's just your makeup. It's your personality. You don't do things the same way every time. How do you think that's working with your brain? Do you build stronger paths by doing things the same way every time, or do you build stronger paths by doing them different ways? You got to build the paths by doing them the same way every time. You got to try to get things normal. You got to build that path first. Once you get the path built, you can then begin to deal with a lot of differences. So just try to be careful and try to do things as much as you can the same way. That's why I gave you an order. All right, anyhow, go ahead. Keep working. Keep working, keep working. That one we don't need to split up because there's nothing we can do with the square root of 29, right? Just move the 6 to the other side. You could. And that's fine if you get x equals 6 minus the square root of 29, x equals 6 plus the square root of 29. How many got that one correct? And hopefully, if not, you found your mistake. Questions? Questions? Move the 9 to the other side. Group the squared terms, take the b value, divide by 2, and square it. Whatever you put in the parentheses, put the same amount on the other side. Complete the square. Take the square root of both sides. Won't be able to do anything with square root of 29, therefore I just need to add a positive 6 to both sides. And I can write both answers as 1. All right, one last problem. One last problem. Go ahead and solve that. See if you can handle fractions. Woohoo! Yippee! Here. All right, so on this one, you're going to take your 5, right, and divide it by 2, and you're going to square it. That's a 5 squared divided by a 2 squared, which, again, is a 5 over 2 times a 5 over 2, right? 25 fourths. Shouldn't be a problem. 25 fourths. Whatever you put on the one side, put the same on the other side. Completing the square. See, some of you, you're worried about writing stuff down. You're not going to watch and hear what I'm going to do right now to complete the square. I'm going to take the sine of the middle. I'm going to take the square root of the front. And guess what the square root of the back is? It's what you had before you squared it. So x plus 5/2 quantity squared. All right, look on the right as well. Look. How many fourths is a 2? It's 8 fourths. 8 fourths and 25 fourths is 33 fourths. You should be able to do that in your head. A 2 is 8 over 4. 8 fourths. 8 divided by 4 is 2. 8 fourths and 25 fourths, 33 fourths. All right, I got to finish up. I'm going to take square root of both sides. I get x plus 5/2 equals plus or minus the square root of 33. And we all know the square root of 4 is 2. Notice that I have a radical. I could split it up into 2, but it's a radical. So all I'm going to do is add a negative 5/2 to both sides. This one is nice because I could actually add the numerators and put them over that common denominator to get the best form. This is the best answer. Negative 5 plus or minus the square root of 33 over 2. But I would take it at your point in your math, negative 5/2 plus or minus square root of 33 over 2. How many got it correct? All right, listen, we did a good amount of practice. Stop, listen for a minute. Did a good amount of practice in class, so there's not a ton of problems, but there are some. Take note of the odds. Make sure you're practicing correctly. Quiz tomorrow. Quiz tomorrow.